Hi, this is number 5 laboratory. This issue is about the study of energy of a moving object with horizontal projection, which has an initial horizontal velocity. Initially, we define as a system property of the mass of the object, that is 0.227 kilograms. Here, the motion of the object for the position and velocity that were obtained as shown in a table in Tracker. Here we obtain the information about the real data about the object that is moving about an horizontal projection. So we can see the motion of this object that has initially horizontal velocity with only x component velocity, and then is falling the object. So in this, with this tracker, we obtain this data, that is the x and y position of the object, and the last time that we defined for the study of this motion. So we have the last time that this tracker obtained data is the time 0.5. So we defined in here as a start counting time 0, the 0.2 seconds, and the object is about to, I define this time because this is the time when the object is about to drop in free fall from this moment. Consider the effect of the drag force, since the position versus time did not agree at first with the real and the simulated data. So in here we put as a proportionate constant b for magnitude of drag force this value, that is 1.85. Data for tracker to compare with data from simulation to the data obtained by the simulation was defined, which is the way to get the energy, kinetic energy and the potential energy. Then I define what is the force of gravity and the drag force. In here we define what is the calculation of the kinetic energy and the potential energy. And in this part of the program, we define what is how to obtain the force of gravity and the drag force. And then the final calculation of the F net to obtain the position of the object, the position of the velocity, and the velocity, the vector velocity of the object. That is the simulated data that is getting for this simulation for Python. First observe, we're gonna run the program. First we're gonna get the position about the two data, the real one and the simulated. First we observe the graph of position versus time for the two forms, real and simulation. The graph blue is the position for the simulation and the red is the real. We observe that the adjustment took with constant drag is pretty accurate. And we can analyze, that is the energy graph, by plotting the kinetic energy and the potential energy. So here we have the two graphs the kinetic, the potential, and the change in mechanical energy. Comparing the graph energies, the energies graph, we can clearly see as expect that energy is not conserved. One possible cause is air resistance, although this case should not be as so significant. But in the graph it's observed that of the blue one is the kinetic energy and the red one is the potential energy. And then we have the green one that is the mechanical energy. So the energy is not conserved. Noting that at one point the velocity and hence the kinetic energy approaches a value of zero, and the change in energy is converted into potential energy practically. Thank you.